Good morning, guys. Just wanted to let you guys know today we're doing inverse trig. Last class when I was with you, we did the 1 day of SOL review that we have for this year. And I'm hoping that a lot of you came yesterday afternoon to boot camp. Please be aware that there are a few more boot camp opportunities available. One of those being next Tuesday afternoon. That's Tuesday the 24th of May. I will be doing boot camp. Everybody's invited. And please don't forget, if you got your invites to boot camp, you're either going today during like a study block or you'll be invited in the morning next week. And please don't blow those off because those really are meant to assist you guys in the best way possible. So, talking about inverse trig, whenever we've been doing trig so far, it's always been, I say find the sine of, and I give you an angle. Whether it be in radians or degrees, I still give you the angle, and then you tell me what the ratio is between the two sides. And sometimes that ratio is a nice fraction, other times there's a radical involved, other times it's just been plug into the calculator and find it. But you guys have always been giving me the ratio. Well, if I know the value, if I know the ratio, I can work backwards to find the angle. So you can use the inverse function to find the angle. So, I want you guys to remember way back when, I think it was like unit 5 or 6, that we talked about inverses. And what we did anytime we do an inverse is we switch all of the x and y values. So instead of it being a y equals something, it becomes an x equals something, and typically we go ahead and solve for y after that. So, if you look over here, I'm going to scroll this down just a little bit. There is a picture on your notes of the inverse of sine. So, if you think of it as the inverse, didn't it used to be rotated kind of like this, and you would have your loops going this way? Now it's just been flipped up on its side. It's been reflected over the line y equals x. So that's something you are going to need to know for your SOLs, is that the inverse does reflect over the line y equals x. So this graph shows that inverse. We write that to start with as x equals the sine of y. Now, I don't know about you guys, but never are you going to see x equals going into a calculator. We don't work that way, unfortunately. We can't manage to find a way to plug it into the calculator so that we can get an x equals instead of a y equals. So we have to be able to convert things from an x equals back into a y equals. So we're going to have to resolve this for y. There are two notations that we use to say that we're taking the inverse of a trig function. The first would be, and I'm going to use sine as an example, but it could be any of them. Sine to the -1 means inverse of sine. You might also see it as arc sine. Both mean take the inverse. Both mean I gave you the ratio, you tell me the angle. Working backwards from how we normally work. So, how are we going to solve? We're going to take the inverse of both sides. Now, before you would just manipulate the equation. You divide by things, take square roots, do anything that you possibly could to get that y by itself. But sine, cosine, tangent, and the reciprocals don't work like that. You can't divide by tangent and make it go away. It doesn't work like that. Tangent is an operation. It's a specific ratio. You can't divide by a thing. It's like saying, let's divide by addition. It doesn't work like that. So, we start with x equals sine y. That's what we had up front. Now, I'm going to use this notation primarily, but please don't be shocked if you see this one. I'm going to take the inverse sine of both sides. So I'm going to take the inverse sine of x and the inverse sine of sine y. So if you don't want to see it in this setup with the longer gaps, you're doing this equals the inverse sine of the sine of y. Now, the great thing about inverse sine of the sine is those undo each other. That's like squaring the square root. These are gone. So now I just have y equals inverse sine of x. So that is how we're going to manage to get into each one of these shapes with the inverse sign going on. So let's start by going back to the graph real quick. I want to talk about when things work. So if you're looking at this graph, clearly that's not a function. It fails the vertical line test pretty much at every single point between the -1 and the 1. Doesn't ever seem to go past, because remember, sine fluctuates. Sine's periodic. It doesn't shoot off towards infinity. It just does its little bounce back and forth again and again and again. So is that graph a function? No, it's not. Nope. So we can restrict the domain. Now by restricting the domain of the original function, it allows us to flip that inverse so that it can be an actual function. Now what that's saying is, if I start here, and I have sine, and sine has done this. When I go to flip that onto its side, I'm now doing this. But I don't want that. I don't want all of that being flipped because now this fails the vertical line test. So what if I only draw part of sine? And I'm restricting the domain so that it's not going to fall on top of itself. So let's say I go here, and I do just that part. When I reflect this, I should get this piece and this piece. That red, right in there, you need to see it elsewhere, it's right here. That does not fail the vertical line test. It passes. So when you deal with taking the inverses of these, there's only specific areas the original function was allowed to be. Otherwise, the inverse doesn't exist because the inverse is not a function. So the way that works is, in order for y to be equal to the sine of x, the inverse